Hi everyone! Today we will create a mobile app with KivyMD, which is officially the best GUI library that I ever got to work with. And I actually have a feeling that you guys will agree with me by the end of this tutorial. So what we will build today is a binary to decimal converter, and of course vice versa. And the end goal of this project is to load it into our Android mobile devices. So of course we will do this together, step by step, and we will load it into the Android device in the next few videos. In this video, we will focus on building the app first. We will first copy the starter code from the description of the video, and this will create an empty window object, which we have called screen. Now, usually mobile apps have a toolbar at the top of the screen or at the bottom of the screen, and that's exactly what we'll do first. So right underneath our screen call, and actually let's replace this message, we will create an empty toolbar with the title of binary to decimal. And then we will assign this expression to self.toolbar. And I haven't had a chance to film a class tutorial just yet. So for now, imagine this self keyword as a prefix to any variable name within the scope of the class. Next, we will set the position of our toolbar to the top. We will do this by typing self.toolbar.pos hint, as in position hint, equals a dictionary where the top key equals 1. Cool. And now the only thing left to do is to place this widget on our screen with add underscore widget, and inside the round brackets our self.toolbar widget. And now we can save this file with Ctrl S and we can run it from our terminal, in my case Anaconda, and we will run it with Python converter.py, where converter.py is the name of our file. And once we're ready, we will hit enter and we see our beautiful toolbar at the top of the screen. Now let's go ahead and add an icon button to the very top right. So right below our positioning command, we will type self.toolbar.right action items, which will equal a list where the first and only value will equal an icon of rotate 3D variant, which is a very conventional icon if you want to flip something. You'll see it soon. And just to make sure that my head doesn't block the rest of this expression, we'll split it to the next line. And since we indicated an icon, we will also need to indicate a function that will be executed as soon as we click on the icon. We will do this with lambda x self.flip, which is a function that we haven't defined yet. And since we want to test how this code works, we will definitely need to define it. So right at the top of our class, we will type def flip, which will take in a single argument, which is self. And for now, we will just print working. So let's save this file and let's rerun it. And as you guys can see, our beautiful flip icon was added to the top of the screen. And if we press it, you can't really see it, but our terminal will print working. And if you guys want to see the full list of available icons, just navigate to the link in the description and copy all these lines of code, then save it as a Python file, and then run it from your terminal. And you can choose your favorite icons from here. So very commonly, you would see dots. Another icon you may encounter a lot is a camera icon, and they even added social media icons, which is incredible. Next on the list of mobile app necessities is a logo. Now you can either use my logo, you can download it from GitHub, or you can use any other image on your computer. And we will add this logo with screen.add widget, and inside the round brackets we will specify an image widget where the source attribute would equal logo PNG in my case, and if you're using any other image in any other location on your computer, specify it here. And we will also need to specify where this logo should be, and we can do this with pos hint, which equals a dictionary where the first key would be center X and its value would be 0.5. This will place our logo at the center horizontally. And then, with the help of our center Y key, we will place our logo almost 3/4 way up from the bottom of the screen vertically. Now let's save this file and let's rerun it. And there's our beautiful logo. Next, we will need to collect a binary number from the user. For this, we will create a brand new variable called self-input, which will equal to md text field, where the placeholder text equals enter a binary number. Now, I would also like to justify this text to the center of our input field. And we can do this by setting the age-align attribute to center. Additionally, I would like to add some margins along the sides of this input field. And we can do this by typing size hint, which will equal to a tuple where the width value equals to 0.8 and the height value equals to 1, which is the default. In other words, the width of our input field would be 80% of what it used to be, while the height of our input field would be 100% as it used to be. And we will also need to position this input widget, so we will just copy this pose hint command from above, we will paste it at the very bottom, and we will only change its vertical position from 7 to 0.45, from 0.7 to 0.45. And then last but not least, as per the suggestion of Paraglide01, we will enlarge the font size from 16 to 22. We can then add this widget to our screen with add widget, and inside the round brackets, self input. And we can see that our beautiful input field was added to the screen, and it only takes up 80% of the available width because we have 10% margin along the left and we have 10% margin along the right, which is exactly what I wanted. Next, we will quickly add two label widgets where the first one will be called label, and this will equal to md label, where the placeholder text will equal in decimal is, and we will copy a few lines of code from above just so we don't have to retype it. So I would like the age align and the pose hint, which we will copy and paste right underneath. We can get rid of the size hint, and we will position this label at 0.35 vertically. And to this, we will add a theme text color, which in the case of our first label equals secondary. And then we will copy this entire label widget, we'll paste it underneath, and we will refactor it. So this time we will name it convert or converted. The placeholder text would be, let's say, 888. We would like it to be placed a little below the first one, so we will delete the 5, and then we will change the secondary color to primary color. Additionally, I would like to indicate that this particular label is very important. We can do this by setting the font style to age, let's say 5, where age represents a header and 5 represents the 5th order of importance. And once we finished initializing these labels, we will add them to the screen. So let's save it, let's rerun it. Cool, so both our labels were added to the page, but now everything looks a bit cluttered. So let's maybe lift the input field slightly upwards. Yeah, and it makes a lot of sense to place it at the center. Lastly, we will also need a convert button. Now, this is probably one of my favorite parts because unlike KivyMD has a fantastic shortcut for rounded corners. So we will type screen.add widget, and inside the round brackets we specify an md fill round flat button. I know it's a long one, but it's worth it, trust me. And then we will open another set of round brackets where the text of this button would be convert in all caps. The font size would be slightly bigger than the default, so we'll make it 17 instead of 16. And we will, of course, copy the pause hint command, because who has the time to type it? And this time we will place it at almost the very bottom, so let's do 0.15. And last but most certainly not least, we will add an onPress callback, which will equal to self dot, at least for now, flip. We will create a proper convert function soon. And we got ourselves a beautiful convert button. Cool, and now let's add some functionality. So instead of our default flip function, we will specify a convert function, and we will scroll to the very, very top of our code and define it underneath the flip function. So def convert. But this time, unlike the flip function, we will need two parameters. So the first parameter will be self as usual, and the second parameter will be args, arguments. In other words, each time you define a new function for a toolbar icon, you always have to specify the self keyword as an argument. While whenever you create a button widget, you always need to specify two different arguments, where the first one is always self, and the second one, you can name it whichever way you like, just make sure it's there. Cool, now let's move on. So first we would like to fetch the number that the user provided us. And we can easily do this by specifying self.input.text, which represents the value provided by the user. And because the type of this value is a string, we will need to convert it to an integer. So we will type int, and we will open a set of round brackets. And here, some of you might be shocked, but the way we convert whole binary numbers to decimals in Python is simply by adding a comma and 2 to the end of our int function. It's that easy. And then we can assign this expression to a local variable name, which we will call val, and this will equal our expression. Note that we didn't specify the self prefix in front of val. That means that our variable exists only within the scope of the convert function. If we will try to call val inside the flip function, it's not gonna work. While variables who have the self prefix in front of them can be accessed from multiple functions, for example, convert and build. And now we can update the 888 placeholder with the converted value. So we will type self.converted.text equals the string instance of val. Okay, so I am aiming for 8, which equals in binary to 1000. Let's convert it. Boom, we got 8. And just in case, let's try to get, let's say 5. We got 5. And actually, we don't really need to see those labels before we press the convert button. So let's go ahead and get rid of them. So let's delete the placeholder text from our converted label, and then we will copy the placeholder text from our label, and we will delete it as well. And then we will scroll all the way up to our convert function, and we will update our self label text to be equal to the placeholder. And now if we save the file, and we see that both our labels disappeared, and now if we type, let's say 15 and press convert, both of them appear. And one of the last things left to do is to take care of the flip icon button, which will flip our conversion from binary to decimal to a conversion from decimal to binary. And since this affects both the appearance of our app and both the functionality of all our widgets, it makes sense to separate our app into two states, where this particular appearance and functionality belongs to state 0, and the decimal to binary conversion belongs to state 1. So first, we will create a state variable at the very top of our build function. We will call it self.state, and this will equal to 0, at least initially. Then we will scroll up to our flip function, and we will begin with a conditional statement. So if self.state equals 0, then we will first change the title of our toolbar with self toolbar title equals decimal to binary without the typo. And we will, of course, update the text of our input field. And we will say, enter a decimal number. And of course, we will need to flip the state from 0 to 1. It actually makes sense to do it at the very top. And additionally, to avoid confusion, we will also empty the text from both our labels. For this, we will just copy these 2 lines of code. We'll paste them underneath, and we will refactor the value to an empty string, as well as in our label. I just love saying label. Okay, so this takes care of state 0. But what happens if we are in state 1? We will type else, and we will actually copy all these lines of code and slightly refactor them. So we will refactor 1 to 0, we will refactor decimal to binary into binary to decimal, and we will ask for a binary number. Cool, so let's press on the flip button. Awesome, it seems to be working. Now let's test it. So let's say a binary number of 1000 equals to 8. Perfect. And then if we press on the flip button, exactly what we expected happens. And the only thing left to do is to implement states inside our convert function. Now, because this block of code belongs to state 0, where we convert binary to decimal, we will include it inside an if statement of if self.state equals 0. We will, of course, indent these lines of code, and we will move on to the else clause, where we will tackle state 1. So we will, of course, still need to fetch the user input with self input.text. And because it's a string, we will still need to convert it into an integer. Now, since this time we are converting a decimal number to binary, we will need to add the bin function in front of our int function. Now, the bin function returns a string rather than a numeric value, and this string always begins with 0b. So let's get rid of both of these characters by slicing them off, so 2 and colon. And in other words, it means skip the first 2 characters, which are 0b, and return the rest of the string, which is our binary number. So now we can assign this expression to our val local variable, and then we can copy these 2 lines of code from above, and we will paste them underneath. And since we just discussed that bin returns a string rather than a number, we will not need this string command. And since this time we are returning a binary number, we will refactor decimal to binary. Let's go ahead and test it. We'll save it. So first, let's see if we get 7. Perfect. Now let's flip. Let's type 7. Perfect. Now, just in case, let's test it on another number. We know that 15 is 1111. So let's see. Perfect. And we also know that 8 is 1000. Perfect. Now back to our binary to decimal conversion. Let's do the same. 15, 7, 8. I think we're good. And one last but very handy trick I will show you with KivyMD is how to switch the default blue theme to a theme of any other color. And we will use deep orange for the example because so many of you guys really liked it. So right before we initialize our screen, we will type self.theme cls as in class .primary palette, which in our case will equal to deep orange. Let's save it. Let's rerun our file. And everything is orange. But seriously, this is really cool. And while I only gave you 2 options to choose from in the community post, there were a lot of suggestions, well, 3 to make it green. Okay, so let's try green. I gotta tell you, I didn't like it, but let's give it a shot. This is how it looks like. And the reason why I didn't like it, it's because I usually like when the text is white. And as I'm sure many of you have already noticed, I've included some of my favorite colors right above my head. But for now, let's see how deep green looks like, because that would probably have white text. Oh, and there is no deep green. So it actually shows you all the different colors available. And it doesn't look like they have a darker green, but let's try the blue-gray. So I'm just gonna copy it. Let's paste it here. Let's save it. I actually really, really like it. Maybe I should have done the app with this color instead. But whatever, we picked the default blue and we shall remain with the default blue. But I just wanted to show you what else we need to do in this app that we haven't finished in this tutorial. So let's say we are entering a string that is not a binary number and we are trying to convert it. Boom, our app fails. So what we will need to do in the next episode is we will need to tackle some exceptions. In this case, we have the value error exception. Another thing we will need to tackle: what happens if the binary number we enter is perfectly valid, however, it has a fraction at its end. Now, this fraction should realistically indicate a quarter. That should be 7 1/4. But what happens when we press convert? Our app fails again and again with a value error. And the reason is this int command only converts whole numbers. What we will actually need to do is we will need to specify a function that can convert both whole numbers and both fractions. Now, if you guys are computer science students, I'm sure you know exactly how to do it. But if you're not, I will show you how to do it in the next tutorial, and we'll do it manually without any shortcuts to make sure we understand what we did. Thank you so much for watching. If you found this tutorial helpful, please give it a like, maybe subscribe to my channel, turn on the notification bell, maybe leave me a comment or even share this video with your friends, with your coworkers. I really appreciate any form of help, and so far you guys have been fantastic. So thank you so much. And if you have any questions, please leave them in the comments below and I'll be able to address them in the next tutorial of this project, which will not take very long to post because I already have the code ready. I just need to film it and that's all. So I'll definitely see you very soon.